Hi, this is a quick lesson on how levers work. So a lever has four main components. The sort of flat platform you see here, that's a lever, and there's a force acting on the lever, which we can denote with an F. And finally, we also have a load. The load is basically just a fancy word for an object you place on a lever, which you want to lift with the force that you apply on the lever. And finally, there's the last component, which is this triangle right here, the fulcrum. Now, how do all of these components work together? We're using the lever to make our job easier. We're using it to make it so that it's easier for us to lift the load. And in order to do that, we have to be able to push down on the lever so the load will go up. Let me show you what this looks like with dry erase markers. So the green one is going to be our fulcrum, and the orange one is going to be the lever. Here we have the fulcrum, and now the lever. This end of the marker is slightly heavier because of the cap. When we place it on the center, it's inclined to tilt this way. If I apply a force to this end of the dry erase marker, then that was previously lying on the surface will now go up. So that's what happens here as well. If we want to lift the load up by a certain distance by applying a certain force, we also have to push down on the other end of the lever with the same amount of force. Now, if we move the fulcrum so that it's closer to the end with the load, so somewhere like here, for instance, now it's a different story. If we apply the same force here, a much, much greater force will be applied to the load. But now you might think, wait a minute, if we're lifting something up and we're lifting the same thing up, it doesn't make sense that just by moving this, we do less work. Well, the truth is, we still do the same amount of work, but it's just that the amount of force we have to apply to do this work decreases. So how does the amount of work done stay the same? Well, as you may learn in the future, but this is beyond the scope of this lesson right now, work is actually equal to force times distance. If you push a grand piano around an entire track field once, then obviously you've done more work than someone who just pushed it for a meter, right? So work should not just be dependent on force. So that's sort of an intuitive explanation of this equation, but essentially what we have here is we've decreased the amount of force, but at the same time, we've actually increased the distance. So that now, if we want to raise the load by, say, this certain height, h, we would have to push the other end of the lever all the way down here. And as you can see, this distance is much, much greater than h. Whereas before, the distance that the force was applied was the same as the distance that the load went up by. That concludes this short lesson on levers. To the Gearing Up team, I just wanted to say that I would really, really love the opportunity to work with you guys this summer.